Marketing, marketing, marketing. Most people believe their business will grow by doing marketing, but many people fail. Let's understand why. People just draw graphs, understand different concepts, understand what's happening here and there, try to analyze. And even though we analyze it, what actually differentiates between you and a champion, a successful business person, a person who can run his own ads in a successful sales. Let's analyze this by taking the input data of sales data of previous 100 sales representatives. So here in this particular data, we have a number of variables. Among these, budget related to advertisement is the key thing to make our sales productive. And final output of this particular project or this analysis is to visualize the data and understand the key concepts, key relationships between the variables, between the futures. Due to that, we can make a proper decision. So here we are going to utilize some statistical analysis like t-test and p-value. And here major concept, ML concept, we are using linear regression to perform the predictions for the given data. So in summary, we are going to take download this dataset, and we are going to take, as I mentioned, we are going to take these variables and get the output visualization in the form of visualization and statistical test results, regression coefficients, and model performance metrics. First, we are going to import our data as well as libraries. Here I'm going to use NumPy, Matplotlib, Pandas, Seaborn. Analysis, we have performed analysis by getting the head and tail of the data. And here the shape of the data is 1,100 features and 9 targets. Here we have 100 rows and 9 columns. So we started performing data visualization, starting with the histogram and line chart. We are trying to understand the price frequency. So as usually you can see it as a normal distribution. It is close to data is close to the mean. So here we can understand that there's very less deviation from the mean. Our mean is 300. So the minimum value to the mean is so less. Very close. So there is no much deviation. So here we can say that we're trying to plot a count plot. We're trying to get the count of SNOs for the given distribution, for the given engineering status. So, and again, we're trying to plot a histogram bar plot for the location, sales location, value count. So for which location, how many sales were done. And next, we are going to perform pie chart for engineering count. So here, distribution of engineering count. This engineering status is yes or no, like almost no percentage, 72%. So engineering count, again, we're trying to we're trying to get a count of experience on how many engineers were experienced. Sales data, experience, distribution of experience in years. Next, we are going to plot a box plot. We have 75th percentile and 25th percentile. We can't, we don't have any outliers here. We have tried to plot box plot for the price and gender count for the sales. How many in the sales? How many people were male and female? And next, we try to plot a pie plot for distribution of gender with respect to sales. Next, we try to plot a budget plot, agency value. And next, we try to plot a histogram plot for sales data, for budget agency data. How much is the frequency of each budget, distribution of budget agency. Here each bin, we are taking 15 samples for each distribution. And next, we are trying to perform hypothesis testing here by using the p-value based on we reject or accept the hypothesis. So final result was based on the t-test, we failed to reject the null hypothesis. This is not statistically significant. Big difference between the mean budget phone and the budget social count media. And next, we try to plot the linear regression model for the quality and price. We try to fit it and get the summary. So intercept is this one, and where the y line started, with the line has intercepted the y axis, the first point. We can without the note standard error assume that covariance matrix of the error is correctly specified. So here we try to visualize the linear regression output. So here we can see that all the data points are close to the line, have been matched. We try to compare the price and quantity. So here let's recap what is t-test and what actual model statistical analysis which we have done. In t-test, we use t-test to see if there is a significant difference in spending between price phone advertising and social media advertising. Our findings were turns out there is no significant difference. So based on our data, companies are spending pretty much the same on both, and any small differences are likely just random. And linear regression model says us is next we modeled how price affects the quantity of solar panels sold. We found a super strong relationship. For each 1 unit increase in price, sales drop by about 2.97 units. This model is incredibly accurate, explaining almost 95% of the chance in sales just by looking at the price. This means pricing strategy is super crucial for sales. Key takeaways are while budget allocation between phone and social media ads seem similar, price is a massive driven of sales for solar panels. Optimize your pricing and watch those quantities more. So let's understand by understanding the futures and the predicted. What futures we have taken and what we have predicted. Again, we are including the t-test here. T-test are our budget different. This was our question. Are our budget different? What's the purpose? What's the main purpose? We want to find out if there is a significant difference between the average spending on phone advertising and social media marketing. This helps us decide if we should adjust our budget allocation. Futures and predicted values. Features which we have included is budget phone and budget social media. These are the two groups being compared. Predicted are whether the mean of these two budget types is statistically different. The formula which for the T independent sample test is mean of x1 and y1 two futures with the square root of sample as a sample variance to the number of values, total number of features, total number of samples plus the other one. So here x1 and x2 are sample means, and s1 square are s1 square and s2 square are sample variance, and n1 and n2 are the sample size of phone and social media budgets respectively. For finding and decision making, our t-test was 0.016 with a p-value of 0.987. Since this p-value is much higher than our significant level, we failed to reject the null hypothesis. Decision making. What decision we made from this? This means there is no statistical significance difference between average spending on phone and social media advertising. So for now, there is no statistical evidence to suggest we must shift funds from one to other based purely on the average spend. Further analysis might focus on the return on investment. For each to make smarter allocation choice, linear regression, predicting sales with price purpose. We aim to model the relationship between the price of solar panels and the quantity sold. This is crucial for optimizing pricing strategy to maximize sales on revenue. Futures and predicted values. Futures, independent values. Price in thousand, which are INR. Predicted values are dependent. Quantity sold and number of solar panels which were sold. The formula which we are using is y is equal to mx plus c. It is here. Y is our quantity, our predicted value, which has been sold. X is the price. Our future, one of the future. B naught is the intercept, and bi is the slope coefficient, and e is the error term. Our finding and decision making. Intercept, which is 128095. This is theoretically quantity sold in the price where if the price where zero. If the price is zero, this is the quantity which is going to sell, which is going to sold. Price coefficient, which is minus 2.97. Statistical significant. P value is 0.00. This is the key insight. Adjusting R square 0.948. This means an incredibly 94.8% of the variance is sold in quantity sold can be explained by price alone. Decision. The strong negative coefficient for price means that for every 1 unit increase in price, the quantity sold decreases by almost 3 units. This highlights the price is a dominant future factor in sales. Businesses should carefully analyze this price sensitivity and consider price elasticity when setting their strategies to avoid significant drops in demand or to find an optimal price point that balances quantity and revenue.